All right, so this week we're going to look at other ways to get inputs from the user. So we looked at the potentiometer using the analog read. So if I turn this dial up, I'll notice a couple of things. One is there's a little LED turning on right here. But if I keep going, you can see there that it goes to yellow and then red as we get towards the high end of the potentiometer. Now, you'll notice this LED is changing brightness here as I change the potentiometer. One of the other things we're going to be looking at is how to affect an LED, but not just turn it on or off like what we're doing here. We're going to make it dimmable. So I wanted to show you though that this one is dimmable, but the reason that it's dimmable is, or changing brightness, is because of the potentiometer. So remember this lead coming out of the middle spot of the potentiometer, right? We've got our 3 volts here, we've got our our ground lead here, but in the middle we have our output voltage depending on the setting of the potentiometer. So one of these leads here, this one here, goes back to our pi pico, and we're reading that value in. And that's what we're using to affect these 3 LEDs. Now, I have another wire coming to the positive side of this LED. And again, the positive side of an LED is the longer lead. So you can see here, this one's the voltage needs to come into this one, and this one needs to go to ground. And normally you put a 220 volt or 220 ohm resistor in that circuit somewhere, like we have with these 3. But in this case, the potentiometer works as the base resistor. And as we change, then the ground side here goes to the ground bus. So as we change this potentiometer, what it's doing is it's changing the voltage, the actual voltage that's being supplied to that LED. So it is dimming it that way. So you can dim an LED by affecting its voltage that's being passed to it. But another way that we can do LEDs and change the dimmable, how bright they are, is by using something called PWM, which stands for pulse width modulation. We're going to modulate pulses and change their width, hence the name pulse width modulation. And those pulses are going to be on and off. That's all you can do for a pulse. But the width of how long it's on and how long it's off is what we're going to modulate or change. And if it's on 50% of the time and off 50% of the time, you'll have a 50% brightness LED. But then if you have it on more than the off in the same duty cycle, then you'll see that it's brighter. And if it's off more than it's on, then it'll be dimmer. So that's how that's going to work. But we'll talk about that in a little bit. But I did want to show you, using a potentiometer like this, you can directly affect the voltage that's going to something like an LED, and therefore changing its brightness. Another thing we're going to look at here is, though, for inputs, is a button. So we have a button here. It's just wired up to our breadboard. The way these buttons work, by the way, there are 2 different kinds of buttons in your kit. We're going to be playing with these bigger ones just because they're easier to see and to use. And they also come with these fancy colored button tops. Those are in a little Ziploc bag in the kit. And you can hear it clicks. The way that a button is wired up is that these 2 leads that point to each other are angled towards each other. Let's see if I can show that well. You see how those kind of angle in towards each other? These 2 are connected, and these 2 are connected. But if we want to connect the 2 on one side here, you have to push the button, and that'll connect them up. So that's why with this button here, we have some additional wires here. One is going into one of the leads, and it's coming out of the second pin on the left-hand side, which that's going to be GPIO 14. So that's the lead we're going to use. And we're going to reference it with GP14 because it's going to be just a digital pin input output, and we're going to use it as an input here. So then we have the other lead going to ground. So what's going to happen is when this detects a connection, we'll get a true, but when you push it, but normally leaving it out, it'll show a false. So if we start monitoring this here, we can see we have our GPIO 14 pin connected to a variable called pin button. We're going to set its direction to input. We haven't done that before yet. And don't worry about this commented line here. We'll talk about that here in just a second. So I'm going to turn on the monitoring so you can say it's false, it's not pushed down. Okay, so there's actually an issue. We're not getting a signal here. The reason we're not getting a signal here is because a button normally needs a resistor to work correctly. And that resistor is going to not be one of the normal 220 resistors. This is a 10K. So you're going to get it out of your resistor bag for the kit. See if that'll focus. No, we focus on here. Yeah, you can kind of see that. It says 10K. Sorry, the lighting's bad. You're going to use a 10K resistor, and you're going to just connect it from the lead that's going into the high, and you're going to connect this to 3.3 volts. And connect it to the red side of the breadboard bus. Make sure that all goes in right. All right. One thing I do want to point out is that I did add another connection between from the plus side to the plus side, and that runs all the way back here to our 3.3 that's coming out of our board, so that both of these buses, we do have two different connections for ground, but then we're using the same bus for 3.3 volts. Okay, so once we add in that resistor, now when we have the button up, we're getting a true, and when I push the button, you get a false. So you can see that it's pretty consistent, but if I take that resistor back out again, it'll work for a little bit. Actually, it doesn't work at all. Sometimes it works, sometimes it doesn't. So that pull down or pull up resistor is really important. And again, that goes from the 3.3 volts to the pin that you're reading from into the Pico. So one thing that I wanted to point out was you don't technically have to use the resistor. It's one more thing you have to wire up and remember and that kind of thing. That's where this commented line here comes into play. The Pico has a way where you can tell it to actually add in that resistor for the button. And so what we'll do is we'll comment out, or uncomment this line and save. Okay, you see it went from false now to true. And what this line is saying is it's saying to make this button a pull button and that the direction should be up. So this is going to be a pull up resistor, essentially, like what we had before. And now when we push the button, we get our correct value. Can't break it by adding in some static electricity. I'm not really sure what happens. It's due to noise in the circuit, but we're not getting that noise now, which is good. So this makes it a whole lot easier to do buttons, but you have to make sure you make it a pull-up resistor, or add in the pull-up resistor code, and now it'll work correctly. So that's how we have a digital I/O input. Our outputs are going to be for things like the LEDs, and in a moment or in the next video, we will talk about additional controls like a slide button. And so let's look at that one. All right, so I've taken out the regular push button, which again just had really an on-off. This one is a another kind of button in the packaging list. It's called a micro switch. These are used a lot in 3D printers and or electronics to know exactly where something is, because it'll sit there and either push against something, and then it knows exactly when it hits it, or it'll sit still and something else will move and tap it and push it. So we're going to use this one now. This is an interesting switch in that it has 3 leads. And the way that you can use the 3 leads is a couple of ways. One is it has a C written on it, and this is only on one side, so you have to flip it over and find out which side it's on. But it's got a C, NO, which is normally open, and then NC, which is normally closed. So depending on how you want to read one of those leads, you can read either of those last 2 leads. And if it's open, you'll get a true, and then when you push the button, you'll get a false. Or if you use the normally closed, you'll get a true, and it'll flip it. And then when you push it, you'll get a false. So we're going to wire this into our circuit here. Okay. All right. Those little leads don't really like playing with breadboard too much. We'll see if that gets read. Okay. You can actually see in the output here that is getting read here. So I just kind of have to push it down a little bit, make sure those leads go in there. But then so we're getting a true by default there. If I move this to the normally, yeah, okay, so now when it's up, we get a false, but when it's down, it'd be the true. So depending on which of these 2 pins you want to listen to, you'll get positive and negative. Your true and falses will be flipped. So that can be helpful. That way you don't have to use some code to determine whether it's open or closed or pushed or not. So that just depends on your use case. So that's what a micro switch is going to do. Let's see. I think in this kit there's some other, they're really tiny buttons. Again, these work just the same as the bigger ones. They're just a whole lot smaller. So yeah, they're one of the big buttons versus the smaller buttons, about half the size. All right. So those are some of the main ways that for now we're going to get inputs from the user. We eventually will be talking about the radio signal or the IR signal from this controller or this remote. We have things like RFID tags, joysticks, those kinds of things. So there are lots of ways we'll be reading things, but remember the main idea is we have digital input and output, and that's just on and off, like these buttons, or we're going to have analog inputs and outputs like the potentiometer. All right, so that's where we get these 2 kind of digital versus analog. All right.